most of you asked me about whether or not there is a sample exam. And the question type will be pretty similar, pretty much traditional. You'll expect traditional questions like the true and false question, multi-choice question, and short answer questions. And questions are very similar to the questions you have encountered on the slides. And we have discussed a lot of our in-class exercise. So the questions on your exam will be pretty similar to those in-class exercise, and also your homework assignment. But you don't have to write a very formal code. So there is no formal coding question. But sometimes I have question ask you to rewrite a given code to find out the security issues of a given code and rewrite the code. And it's a closed book exam, so it's not open book. And the exam will cover the basic security concepts. And today's lecture, I'll just review about those concepts. So to prepare for the exam, so I would suggest you focus on the questions on the slides, and also focus on the content of the slides. And the first basic concept was studied about security is that security is a holistic concept. So it combines physical technology and policies, combines physical technology, security, and security policies. So we can eventually get good security. And for the basic security concept, you need to understand the basic concepts like authentication, authorization. So if I ask you, for example, what does confidentiality mean? Then you should give the proper explanation about confidentiality, integrity, availability, something like this. And authentication is to prove the identity. So generally, there's three ways towards authentication, like something you know, like password, and something you have, like tokens, and also your biometrics features. And authorization means we give some access to particular users. And towards authorization, we use a tool that is called access control list. And in the class, we discussed about the access control list. And for the examples, so we discussed the two examples of access control list. And you may want to review the slides to understand what are the access control lists. And the confidentiality is an important term. And it's pretty straightforward to come up with the meaning of confidentiality. We just want to make sure that important information is in the secret form. So unauthorized person cannot get access to the sensitive important information. And usually we use cryptographic method to achieve confidentiality. And later in this semester, so we'll discuss some basic terms in cryptography. And data integrity to make sure that the original information is not modified by unauthorized person. And cryptographic methods like the hash function, key hash function, and message authentication codes. So those are the main techniques that we can use to achieve to ensure the message integrity, to ensure people to be aware about the message if the message has been modified. And accountability. So accountability means we want to determine, decide who's the attacker, and what is the attack path. And their availability, resource and information, resources, utilities, that they should be always available. So those are the terms of those security. So those are the definitions of those important security terms. So make sure that you understand those terms. And non-reputation, and is also one of the security services, traditional security service. And basically, there are three security objectives like confidentiality, integrity, availability. So if in your test I ask you what are the typical security objectives, so you should be able to name its integrity, confidentiality, availability. And we also discuss some attacks and try to understand the meaning of these attacks. So you can take a look at textbook and take a look at slides to try to understand what are those basically security threats. And in the textbook gives you a simple web server example. And this example is a Java code. And the Java code is full of vulnerabilities. And we look at the vulnerabilities of this simple web server example. So we know this major, so the first vulnerability is a denial of service attack. So why, if you look at this code, so you know if the attacker provide zero input to the simple web server through the socket communication, through the socket connection, then this can cause the server to crash. And in order to solve this problem, so we need to handle the errors. So use try and catch to catch the exceptions. So once the exception happens, for example, there's no input from the attacker, then the server will going to process this exception. For example, the server will just close the socket communication. And there's another vulnerability with the simple web server is that it allows user to request a file from the server, but it does not confine the permissions of the user. So this means the user can actually request whatever files on the server. And if the server has a root privilege, then some important information can be leaked to the attacker. For example, if an attacker asks the shadow file, and the shadow file is special Unix file, so it has all the user's passwords and also the user account information. And the attacker may try to request for such information for such a file. So the lesson we learn is that we should check the path. So make sure that we only offer the remote client. Potentially, it may be a potential attacker. We only offer the remote client or file that is under the working traditional normal working folder, but not under the root folder. So we need to check the path. So in a simple word, if the attacker, if the remote client asks for some file that beyond the client's permission privileges, then the server will just deny such request. And besides the information leakage, and the simple web server, this example is also vulnerable to the denial of service attack, even if we use try and catch, even if we use such statements, because the denial of service happens if the attacker asks for the random file. So the random file is a special Unix file. So its size is 0, but it actually is continuous. It's an infiniteness file. So the size is 0, but actually when the attacker requests the random file from the server, then because random file will never end up, so it's an infinite file. So this will just cause denial of service because the server will be always busy in serving the attacker, so it cannot serve other users. So that is denial of service attack. And so the lesson we learned is that in order to fix this attack, and we'll just enforce a download limit, and not only check the file length, but the random file is special file. So if we want to check its file length, so the operating system will only return you a length of 0, but it actually does not exist on the disk. And the method is that we can impose a download limit. And for example, each client can only download 5 megabytes each time, like this, so that we can prevent the denial of service attack like this. And in the exam, probably I'll give your source code, maybe in Java or in C, and that you read this review, audit this source code, and identify the vulnerabilities, and then revise the code to make it a secure code. And we also discussed the virus, worms, Trojan horse, and other concepts about malwares. And you need to understand the concepts about those malwares. And the next thing we have discussed so far is about the function, is about the calling convention 32 Inter-x86 calling convention. And first we discussed once you have a program, and this program is a source code. So that's a source code in C, for example. And eventually this should be translated into the machine code, so that the CPU can recognize this code, can understand this code, and execute this code. And we discussed the general steps to convert source code into the machine code. And for x86 architecture is an important thing that you need to know, especially for the questions we discussed in the class. And x86 we discussed about its registers. So from EAX to EBX, ECX, and EDI. So we know x86 has 8 registers. And there also have other, it also include other special purpose registers like EIP and eFlag registers. And we can actually refer to the partial information. We can actually refer to part of the register. For example, if we say EAX, we know EAX refers to all the register, all the 8 to 32 bit of the register AX of this register. So EAX means, well, just handle, we need to handle all the data that is of 32 bits of EAX. And AH, it refers to the middle 8 bits from base 8 to bit 15. So AH refer to this portion. And AR, it refers to lowest 8 bits. And AX, it refers to the lowest 16 bits of EAX. And compared with 32-bit processor, 64-bit processor, it extends other registers. So from the first, the name changes. The name is no longer EX. EX is changed to RAX. And 64-bit processor use R to replace E, the prefix E. And also it includes another extra 8 registers that is named from R8 to R15. So this is the difference between the 86 and 64, 32 and 64-bit processors in terms of registers. And we discussed about the assembly language in the AT&T style. So we'll focus on the AT&T style. And even for the midterm, so we'll stick to the AT&T style assembly code. So there are some assembly code examples that we discussed in the class. And you need to understand those examples. And for example, you need to know, so if you see the assembly instruction, move, parentheses, percentage ER, percentage DR, you need to understand what this instruction does. And you need to compare, if I ask you to compare with move, percentage EX and percentage DAX, so for both instructions, you need to understand what is the difference. And so in the, on the slides, I actually give the answers. So you need to review these answers to prepare for the midterm exam. And we also discussed how we can move data from one register to another register. And in addition, we also discussed how we move data from the memory to the register. So you need to know how we do this. So if you say move 0x that if percentage EX, so you know after this move instruction, is completed, then the content of EX should be the content that is stored as the memory address deadbeef. But if you see the dollar sign that move dollar 0x deadbeef to percentage EX, after this instruction, so the content of EX is just the deadbeef. And load effective address is a lead instruction. So you need to understand the lead instruction. What does this instruction do? So this instruction actually it loads the address but not the content. So if you have the lead deadbeef percentage EX, so this is pretty much similar to the move dollar deadbeef percentage EX. So after this lead instruction, so the content of EX is just a deadbeef. So that's why it's called load the address, load the effective address. And we practiced some examples in the class. Those examples are pretty important. And I have the answers on the slides. So review these examples. You need to review all those examples. Question?
All right, 2 slides. Back to the deadbeef example with low effective address. Yeah. Can you explain again why you would load, so why it would be more similar to the lower move than the one above it?
That's why, because the lead instruction, it loads the address to the register, not loads the content of that is stored at some address to the register. So it's like it's just like the move dollar deadbeef. And why? Because for the lower half of this one, deadbeef has a prefix that is dollar. So if you see the dollar, so that means the number after dollar is considered as a constant number. So this constant number is moved, is copied to the register EX. So anyway, so we can just memorize that some number like deadbeef percentage EX pretty is similar, is same. It has the same consequence as if you use move dollar deadbeef percentage EX. Okay.
So you're saying that with the iterations, like you move the address into the other one, so effectively you move the value.
Right. Sounds good. So that it can effectively use value.
Okay. I have a question for you.
Oh, question?
So, like, for dollar sign, which means immediately, right?
Right. It means immediate number, constant number. Right. Correct.
So, for move, like, decimal and EAM, you're using for the only value, or for second one? So, for the order, to get from memory, you use the one.
Because move instruction can move the data that is in memory to the register, or it can move just an immediate number, constant number into the register. So if there is no dollar sign, then just move some address, just move like this 0x deadbeef percentage EX. So it means that the data in the memory is copied into the register. But if this address, in this example, the address deadbeef has a percentage prefix, has a percentage sign, has a dollar sign, then that means the immediate number is copied to the register.
Oh, so for first one, you're using for the order. For the second one, you're using for allocate, not allocate memory. You're using for the surface address.
I'm sorry?
So for first one, you're using for the order. For the second one, you're using for the personal values, right?
The third one is considered as a value. So it's like more like a direct move. But the first one is like you said, is indirect move.
Oh, okay.
Question? Question?
So just to confirm, so basically we don't use the dollar sign, we are basically sending the control deadbeef into the EAX register, but if we use the dollar, then we're not sending the deadbeef, but we're sending the number to the register, correct?
I don't know if I really quite catch your question. So are you asking if there is a dollar sign? If there is no dollar sign, they will move data in the memory to the register.
Yeah.
Yeah. So if there's a dollar sign, then we just move this number into the register. Okay. Any other questions? No question? Okay. And we also discussed another thing. We discussed many things. For the how compiler in the previous lecture, we discussed how compilers can implement the control flow. Basically, it uses jump, the GMP uses jump statement. And in order to implement the branch, then the E flag is used to test the condition. So these are the basic thing you need to know, but you don't have to know the very details about this. So then in addition to the assembly instructions, how we move data from memory to the register, how we move data from register to register. Then we also need to know how the memory, how the code, binary code is executed by the CPU. So as I mentioned many times, once you have the source code, then your source code will be considered, will be actually divided into two parts. The first part has a code, which has instructions. So those are the implementation of the source code, implementation of some certain tasks. And also the data segment. So the data segment consists of all the data. Like if you define an array buffer, like you define the variable, you define global constant, you have the local constant. So those things, they are the data. And data will be loaded in the user to the user stack. And the instructions will be loaded to some memory region that is right below the heap. And the heap stores the dynamic data structure, like if you have used malloc and calloc. If you use malloc to allocate more memory, to request the memory from the operating system, then this memory goes to the runtime heap. And also the codes will be loaded to some other locations of the memory. Also, different programs have a different view of memories. So because the operating system and the hardware use some special techniques, which is called virtualization, such that whenever you have the program, and when this program runs in computer, then if you pull out the runtime memory of this program, so you'll see the program space that is from 0 to 3 gigabytes for the 32-bit Linux system. And each process has independent view of all the 3 gigabytes of memories. But for processes, they cannot view each other's memories. Because if they can do this thing, then that's pretty dangerous. Because some one process may read, for example, like I said, username, password from another process. So that's very dangerous. So the computer usually use isolation technique, which is called virtualization, to participate on the memories for different processes. In the user stack, we discussed what is user stack. We know the memory, it actually goes downwards. And we also practice how the function, how compiler implements the functions. So you are doing this for your homework. And for the Buffalo Flow lab, for the hands-on assignment, for the Buffalo Flow lab, you'll also practice this. You need also to practice this. So I will not talk into the details. And And some of you asked me what does CDR mean. So actually, I did not mention very detail about CDECR. So it's actually it's called C declaration, and it's about all about the calling conventions, compiler calls the functions, implement the functions. And in 64, we discussed 32-bit machine, but for 64-bit machine, it's different because some additional registers are used to execute programs, and then the calling convention is a little bit different. For example, for the 64-bit processor, and sometimes the arguments they are loaded directly loaded to the register, not the memory for the efficiency purpose. And so far, we discussed about the 3 control hijacking attacks, like the buffer overflow attack, integer overflow attack, format string vulnerabilities. And the integer overflow attack is a bit different from the other 2 attacks. And I give you examples about the integer overflow. So, for example, in this example. So this example is an integer, it has an integer overflow issue, and I have an explanation. So you review the codes and understand why it's not secure and how we can make it secure. And like I said, in your midterm, so you can expect questions like this. For example, I give you example code. Actually, that would be very simple code. So I give you a very simple code like this. So ask you about the vulnerabilities. So you should point out the vulnerability and rewrite the code to make it secure. And for the buffer overflow attack, the concept-wise, conceptual-wise, is very straightforward. And that's because reason of the buffer overflow because C is not a tab safe, it's not a safe language, and some functions was designed in a way that they don't do the boundary checking. So this can make a C language is not a safe language. Also, the C language enables the memory operation, so you can use the pointers to directly access to the memory. So those can contribute to the fact that C is not a tab-safe language. And one thing you also need to pay attention is that for the buffer overflow attack, and the attack, the basic idea is pretty straightforward. So attacker just use attack string to overflow the return address so that the program can jump to the attacker's malicious code. But sometimes when the attacker's malicious code need to take some arguments, then you need to know how the attacker can pass the arguments to the attacker's malicious code. And I have an example here. So you need to review this example to understand how we can pass, how attacker can pass arguments into the attacker's malicious code. So basically, the arguments should be located at the position for the 32-bit system. It should be at the position of the EBP +8. And format string vulnerability is another control hijacking attack we discussed. And I also have example about the format string vulnerability. So like in this example, so the main function on the top, so this main function that's labeled by the orange color, this main function has a format string vulnerability. And the green, the main function that is labeled in the green color is a safe function. So you can understand why the previous, the orange function is not safe, and the green function is safe. So you need to understand why, and then, for example, if I give you the code, then has format string vulnerability, you can rewrite it so that it's a secure question.
So for percentage F formatting, which is for the language you write?
it can prevent, it does not do the boundary checking.
Oh.
I don't see how boundary checking is relevant here. But why the green code, the code labeled in green is secure? Because it uses a template. The first is %s, the second is argway. And if the attacker want to inject additional %s, for example, in order to cause the format string vulnerability, and the compiler will, because the template does not seem to be correct, the compiler will just read an error message. And the fundamental reason for the format string vulnerability is that the attacker can inject many %s. And so if you use a template, printf template like this, then you can prevent attacker to give many %s. So this can actually be detected by the compiler, and then the compiler will raise alert, raise error. So this code then, if the attacker want to inject the format string vulnerabilities to the code, then attacker's code after modification, it will not pass compilation. And for preventing hijacking attacks, we briefly discussed the techniques, and you need to understand what are those techniques. Like the first is non-executable memory. So if it makes the memory non-executable, then attacker's malicious code normally is carried by the text string in the buffer. So the code that is stored in the buffer is not executable, so that we can somehow we can prevent the control flow, the buffer overflow attack. But this does not address return to legacy attack. Return to legacy attack, we discussed this. This is the return to legacy attack, and actually for the buffer overflow lab that you are doing right now. And it actually is a return, it's a return to legacy attack. And the return address will be simply modified to some address that is associated with linked to some functions in the shared library. And in order to deal with the return to legacy attack, randomization is one technique. And we can also use the runtime checking, which is a canary. So we use a canary, and this technique is called stack guard. And you need to know what does a canary mean, and what does stack guard mean. And for the isolation and the further isolation and separation, and those are content beyond the textbook. So the course material, like I said, for this course consists of two parts, and the content from slides and content from the textbook. And the content from the slides actually extend the textbook. And for separation and protection, and you only need to understand the basic concept. I will not ask you very detailed questions, technical questions, but you need to know what resources need to be protected, and what does separation mean, and what does isolation mean, and what does sandboxing mean. And for the hardware perspective, we use memory protection, we use the PG and segmentation, so that we can separate the views of different programs, processes. And from hardware perspective, we use something that is called a sandbox. And the virtual machine sandbox, Java virtual machine is an example for the sandbox. And virtual machines is also an example for the sandbox, but it combines both hardware and software techniques. In Java, we discussed the Java virtual machine. So compared with the C language, the Java language is a type-safe language because the Java language is more like an advanced language. It does not support a pointer, so that users, developers cannot directly access to the memory. And also Java Java virtual machine uses security manager, so that the security manager will communicate. The Java program can only communicate with the operating system through the security manager. The security manager checks permissions, checks web violations, and all the Java programs must use the Java API. So because Java function is implemented based on the Java virtual machine, So Java is called a type safe language. But C is not a safe language. And the buffer overflow attack, control hijacking attack, they don't happen of the Java codes. And type safe language, because language is of type safety. So I discussed what does type safety mean. And you need to know what functions are not safe. Of course, C is not safe. And Java has some C#. So those advanced languages, they are called the type safe language. And for the virtual machine monitors, so you don't have to review this part because we haven't finished. So I'll cut out this slides from midterm review. So that's pretty much of what you will expect. So what the midterm will cover. And if you have questions, just let me know.
What is the weak function in Java?
What is a weak function? What function?
Yeah, what function is weak in Java?
What functions do you need to use in Java? What's the question?
No, not like, for example, like can copy or
Oh.
if like function.
Those functions, like the string copy, map copy function, so they are not safe for C. But I don't know if Java has a map copy function. But if you use a string copy function provided by Java, then you don't have to worry about buffer overflow attack. So it's a safe function.
Is everything in the slides? Everything you need to know?
Will there be any information coming from homework too, like this kind of review? Is there anything that we from that homework or no?
Anything come from the homework? Is the question?
Look, I'm just saying, will there be anything from the homeworks or?
Any questions from homework? No.
Oh, so for every exam.
You don't. So you will not have exact questions from the homework, but I think review. I think most of you did quite well for the homework one. So just review your answer. That will be helpful for you to understand the content.
But is it for homework 1 and homework 2 or just homework 1?
So for homework 2 hasn't is not due yet.
Oh, okay, so
And-
it's not gonna be an exam.
And for homework 2 and the lab, you can just put it aside. When you prepare for the midterm, so you can focus your answers. I think ChatGPT may be helpful for you to answer the homework one. So anyway, most of you did a great job for the homework one. So you can review your answers and then review the questions on the slides. Okay. Question?
So is everything we need to know in the midterm review, or should we still review the other slides, or the other lecture slides?
Because I would suggest you focus on midterm review.
Just those slides?
I would suggest you focus everything.
Everything, okay.
But if you don't have time, so you just look at the midterm review.
Okay.
Because that includes the core information.
Everything, okay, thank you.
Okay, question?
Could you cover the format string vulnerability one more time? I'm not sure I understand.
The format string vulnerability. And for the format string vulnerability, so if you say, for example, you have the code like this. So there's a main, so you can see this code has a main function. And the main function has two arguments. The first argument, that's the number of inputs, user input, are the way that is user input that main function can read from the command line. And if the user input, number of user input is larger than 1, argc is larger than 1, then this main function will just call the printf function to print the user input. Okay. And the printf function is actually interpreted by the computer in this way. So you can see in this example, this example, the printf function it tries to print 4 parameters for variables A, B, C, D, E. So it uses a format string percentage D, percentage D, percentage D, percentage D. So this is a safe, secure use of the printf function. And when the CPU finds this printf function, so the CPU will do the following thing. So if there is no percentage, then the CPU just copy it to the output, just printf. For example, A there's no percentage before A, then the CPU just print A on the screen. But if the CPU sees percentage, like this percentage D, the CPU will just search the stack, will search the stack until it finds search stack and fetch the data from memory and output this data. So if your printf function is a printf argv, suppose the user has a hello message, has input is hello, then the function will just printf, just print display hello and on the screen. But if the user input is something that is strange, so this is something that is weird, like hello percentage s percentage s percentage s. And when CPU says hello and the blank character, then the CPU will just print hello on the screen. But when CPU says percentage s, so it will going to check the memory, check user stack. So there are two consequences. The first consequence is that if the CPU goes to the invalid memory, then the program will crash. And if the memory is valid, then the CPU just print this memory on the screen, so the information can be leaked. Question?
Yeah, so if you did that, if you put in a bunch of percentage s's, what values are going to be printed? Assuming the program doesn't crash, like what kinds of values is it going to find? Is it just going to be random stuff?
That is hard. Then what value will be printed? That's a good question. Actually, most of the case, the program will just crash. And sometimes some values, like the sensitive value, like user credential, that is used by some. I think there's some value that should not be displayed, like the user's password, something like this. The program reads from the remote cloud server, but the program is not supposed to show this to the user, to the attacker. So it's hard. It's hard to predict what information attacker can pull out from the memory stack. But anyway, those information can be leaked if the attacker try to use this format string, exploit this format string vulnerability. Question?
So if we want to use prevention, we have to use for hello and launch of string format, and then the program vector was one.
Yeah, if we want to fix this issue, then you have to use your format like this. So first, you define, you use this percentage x argv, so you can define how many values, how many variables should be displayed on the screen. And if there's the input is hello percentage s percentage s percentage s, then when the compiler sees this code, and then the format does not seem to be correct, so it cannot pass the compilation.
So, like for example, if we want to like pick up argument vector 1 and 2 and 3, we need to make it like formatting like 3 and
Right, three.
Because like I was confused over like if we just bring about hello and like bunch of 3 and then with the argument vector, it's going to be causing a lot of
Actually, in this example, there's only one input that the program can take from the user from the screen from user input. So this code can pretty address this question. I think we can have the break. If you have question, you'll just let me know. And if you don't have question, good luck. See you on this Monday. Okay.